Hello. Thank you for attending the Harrington Group International webinar on software validation do's and don'ts. This presentation started a long time ago when I sold quality management software to one of the FDA labs. I actually met with the team that wrote the validation requirements, and I learned a lot, but it's still confusing. So if validation is the confirmation by objective evidence that the previously established requirements for use of a process or system are met. Okay, and then they say, well, with the establishment of documentary evidence that provides a high degree of assurance that a planned process will be uniformly in accordance with the expected specified results. All right, and then the documentary evidence generated through the collection of scientific evaluation of data obtained in qualifying and specific tests throughout the entire cycle of the product, which aims to demonstrate the functionality, consistency, and robustness of a given process and their ability to deliver a quality product. Regardless of what definition you use, what needs to be done, and most importantly, what does not need to be done, is the issue. The main message from this event is validation coverage should be based on the software's complexity and risk. We have great attendance today from around the world, and thank you for those attending in crazy time zones. The phones are muted, but we have a Q&A time at the end. If you have questions, please type them in the questions block. A copy of the presentation can be downloaded now through GoToWebinar. If you have a problem with that at all, just send me an email and I'll send it out to you. And a certificate of attendance will be made available and provided. Let's just talk scope in general, because we got a mix. We got some FDA companies, some automotive companies, some aerospace companies. Cars, planes, medical devices, or anything, if it doesn't work, people might get sick, injured, or die is the scope. And we're adding software into almost everything. The average vehicle today contains about 150 million lines of code. It makes up a large part of the car's value. And new features is gesture control, self-driving abilities, voice interaction. There's a lot going in there. And I'm sure you've seen the problems with the Boeing 737 crashes, and software was telling the pilots the wrong things. So this is a very important subject with different impacts depending on what you're doing and what motivates your company. So let's just start with that. What is driving you? Compliance is compliance. And this is one of the areas that I've got a warning. Be careful. There are consulting firms out there telling you have to validate everything every time. And that's where I get a lot of calls, people just frustrated. And what I've learned is without a connection to business excellence that's considered by management as this whole validation is just a waste of time and money. And it keeps companies from making improvements, even small improvements, like going from paper forms to spreadsheets to a database tool. So my point is you can have both. But my warning is if you're driven strictly by compliance, you may end up spending a lot of time and not helping the business at all. So let's talk business. First of all, do I have to validate all software? No, absolutely not. Well, what software do I have to validate? Well, remember, based on risk. Risk to the end users of your product, of course, is the primary risk, but also the risk to your company. Now, from the FDA document, they specifically say you should consider the least burdensome approach in all areas. And the guidance reflects review of relevant scientific legal requirements. Again, it's changing a lot right now, so this is kind of a tough subject. And this is speaking with the people at the FDA that wrote the requirements. If you believe there's an alternative approach that's less burdensome, talk to them about it. So back to scope. As I mentioned, I sold QMS software to the FDA for use in their labs. I've spoken to the people that wrote it. And again, this is another careful slide about people telling you they have to validate anything. There's a lot of frustrated companies, especially smaller companies, that say We can kind of sort of validate our manual process, but we can't afford software validation. Companies say that we have to validate our ERP system. There's one person, no kidding, that said they were told they had to validate Windows. So this is a be careful slide. So again, just narrowing the scope a little bit more. Does the software impact safety? Does the software impact product quality? Does the software impact system integrity? And, okay, some words in there. Impact has a strong effect or risk on someone or something. And safety is preventing the system from reaching dangerous states. And the reason I put those in there is for the car people today. There's a lot of software going into the cars, and most of the safety or the safety issues in the software have kind of gone into if something weird happens, a shutdown mode. Cybersecurity, of course, is important for medical devices, airplanes, everything. So the software impacts our world in a lot of ways. Almost everything we touch from the beginning to the end of the day relies on software. We mentioned cars. We talked about flight controls on airplanes. Nuclear power plants, they all rely on complex software code that has to be updated from time to time, tested and supported. But for product quality, this is an area that you need to review if the software is fully automated or involves humans. Because again, depending on what the software is doing, if it's not doing it right, people aren't going to catch it. But if there's some layer of humans involved, humans have a lot more flexibility and ability to look at if something's working about. So what about system integrity? Well, an example is in the United States, corrupt software introduced by a contractor shut down the FAA system, so all planes were grounded. So if you saw it, this isn't a software testing or software validation issue, but it's definitely a software lifecycle issue. And it was annoying to the passengers stuck in the airplanes, but it could have cost lives with near misses. So it seems we need to define software scope and impact. Software validation must be considered within the context of the overall design, build, and maintenance of the system. And keep in mind, end users really care about the software. And what I mean by that is, how it was built or designed or whatever, but they do care about the intended use. If I get the wrong blood pressure reading from a medical device, that's an issue. Back to cars, if the brakes don't work, anti-lock brakes don't work, that's an issue. And for those not in automotive, the wiring that used to go to brakes are gone. It's now a chip. And of course, airplane controls, on and on. So for the manufacturing people on the call today, we need to understand the differences and approaches used for product quality. So are they the same concepts? Yes. Prevention versus detection is still around. You can't inspect quality into the result. Look at the whole cost of quality. So conceptually, it's the same, that you apply or think about when you're doing product quality in manufacturing, but it's not the same thing. Seemingly insignificant changes in software code can create unexpected and very significant problems elsewhere in the software program. The vast majority of software problems are traceable to errors made in the design and development phase. Now, that's similar to parts. It's a lot easier to fix them in the design phase. But one of the most significant features of software that's not really part of the manufacturing part mentality is this concept of branching, the ability to execute different series of commands based on different inputs. And another major thing is software like the FAA example has the speed and ease which it can be changed, has a major concern about change management. And like the FAA example, these failures occur without advanced warranty. Again, in cars or airplanes or other devices, I hear noise, vibration, something's not working. So, yes, sort of the same as what the manufacturing quality people on today's call think about, but it's not the same. And artificial intelligence is a whole nother subject. We'll talk about that later. So to drive a little bit further, where's the software used? And again, are there humans involved in the process? Enterprise systems often require human intervention for a good reason. You know, the manufacturing execution systems, the MES, that helps manufacturer execute production plans by implementing work orders on the shop floor. Intersource resource planning, ERP systems help manage production schedule. The MES software helps manage manufacturing operations, and it allows you to track and do things. But the question is, the business question is, will people get injured or die if the ERP entered the wrong number or cost? Or if the MES reported the wrong production quantity? Now, those are kind of high level. The SCADA, PLC, programmable logic controllers, they help monitor operations. And the data goes out to these devices that communicates with equipment. Now, this area may impact quality and safety. Wrong temperatures sent in, wrong times, wrong site. I mean, there's all sorts of things that could go wrong down at that level. One other thing that's not on the slide that can have significant impact, namely accepting bad parts and rejecting good parts, is the CMMs. So the question still is, so what do we have to validate? You need to validate these. Software that itself is a product. Software used as a component of a product. So we bought a car, we bought a medical device, we're in an airplane, there's a bunch of software in there, but how does it impact the overall product? Now, the last slide was software used in the production of the device, and that's where it gets a little fuzzy. You know, do we have to validate ERP? Do we have to validate MES? And, you know, the FDA specifically calls out software used in the implementation of a manufacturer's quality system. So they do call out QMS software, but one of the points I want to make is validation is keeping you from making improvements, taking baby steps. Then we got to go back to this business excellence issue as well. Remember, if we go to our management team and just say we have to spend all this money on compliance because somebody said we had to, but there's no connection to what we're discussing now, it probably won't get funded. Excuse me. So what's the risk of what you're currently doing, and what would be the impact of some simple improvements? So if you look at, you know, software used in the implementation of a manufacturer's quality system, there's still a lot of companies, especially startups, a lot in medical device where they're doing research and development soon. Anyhow, they start with manual and spreadsheets. That's all they got. You know, manual might be okay, especially if you're a small business. Spreadsheets, probably not. Hopefully everyone on today's call knows about all the problems with spreadsheets. So the idea of moving to a database seems like a good idea. I mean, it's better, but they're usually not connected. Another major point. If you try to go from where you are today to be perfect, you'll probably spend a lot of money and fail. Now, the FDA published this concept of quality management maturity model, or QMM. And what it's saying is, as you move in here, there's some workflow involved, interconnected processes, rule-based automation, integration with ERP and MES, and trends and all that. The way to start tying it all together. And again, the artificial intelligence, machine learning, the validation is unclear in that space right now. That's a whole nother hornet's nest. So what's a simple view of the software validation process? Always, always, always start with a discussion about risk. I've done it several times with executives of big and small companies, and we talk about risk, they get it. But if you're going to your executive group looking for money saying, oh, we have to for compliance, it doesn't sell well. So the risk assessment done properly, and there's different ways to think about, what's the likelihood of it happening, and how often does it happen, and our ability to detect it. There's a lot of thought about, failure mode analysis and risk priorities and all that. That's a whole nother subject. But the risk assessment should highlight the critical components, not everything, but these are very important. I mean, it's the classic Pareto analysis, the important few versus the trivial many. So back to my initial comment is, do we have to validate Windows? Probably not. Do we have to validate Excel? Well, you don't have to validate that Excel is performing the right equations or logic you put in it, but you probably do have to validate your logic. I mean, you'd want to do that anyhow. It's good business, right? And ERP, probably not the software, but how you're using it may impact it. And back to QMS software right now, it depends. Again, spreadsheets are high. Internally development databases is better than spreadsheets, but it's a little higher risk, depending on what you put into it. But if you're buying quality management software from a proven software provider, commercially off-the-shelf software, COTS, the impact is usually pretty low. And we'll talk about that. And again, the level of software validation has to be consumer with the risk. There's a couple of people on today's call that I've already talked to that are wrestling with a proven software provider. And again, when you're trying to buy a quality app for $5,000 and you're looking at spending $50,000 to validate it, this is where the business decision is often motivated strictly by compliance-driven mentality versus the business risk. What is the risk from the vendor you're looking at? Commercial off-the-shelf software vendors that have been in business for some time have robust software testing and software validation. Several of them, and I included in the slide, HQMS, the Harrington Group, publishes a statement of software validation that we have gone through and performed this. Now, a little bit more detail on this when I talk about the vendors. I mean, most of them have software requirement specs, a complete description of the behavior of the system that they're working on. And just to be clear, getting back to the manufacturing view of quality on parts and the software issues, testing is the same as like testing parts. There's no bugs and everything works. And again, that's good. However, if you remember, the FDA quality maturity model talked about interconnected business process. That is more around not specs where I didn't get a bug, it didn't click. It's not that. It's a set of use cases that describe the interactions that the user are going to have, when they're using the software. And again, just as a quick side note, I mean, do you validate your car software, the software that's doing all the stuff in your car? Well, most don't, and the reason is there's a level of trust. So what is needed to test and validate software? The minimum support twos, after you've done your risk assessment, after you've identified the important few and pushed aside the trivial many, it's pretty standard. Now, this is pretty simple stuff to explain to executives. Document how we're going to do it, train the people to perform it, audit their performance, and take corrective actions that you find in the audits. And by the way, the corrective actions should be for both problems and improvements. As you engage, you usually get a lot of feedback. Boy, this would be better. This would be easier. Document them both. And that's okay. If you find the software issue, go back to your risk assessment. Is this something that could have airplanes shut down, cars lose control, devices, medical devices give you wrong information? Well, that's a kind of important thing to assess. So let's revisit this verification and validation again. Remember, finding a bug in a software is annoying, but it's usually not a big risk. Finding a broken process between how documents are connected to training and new employees and how audits of them and how corrective action, it could be a major issue if your internal audits aren't finding things like this problem occurred because we gave them the obsolete documentation, or this problem occurred because people aren't trained on the documents, especially changes to them. Another classic is corrective action effectiveness was never performed. These are all things that you have to go through. But remember, if you're currently using paper and spreadsheets, a database is an improvement. It's not perfection, but it's better than what you have now. And as you know, I mean, the people on today's call, a developer can't test forever, and it doesn't guarantee defects, just like manufacturing. You can't inspect quality into the product. Software validation is frustrating because it's hard to know how much evidence is enough. But what it really is developing a level of confidence. Well, how much confidence do you need? And I don't mean to answer a question with a question, but the question is, how much risk is there? So how much validation evidence is needed? Consumer with the risk posed by automated operations. And in that statement, automated operations is the key part. And this is where a lot of people get messed up a little bit. What's the software doing and what's the risk? Again, driverless cars are big, airplanes is big, medical devices is big, but what's the intended use of the software? And did you write your own, or is it COTS from a proven supplier that can give you a statement of software validation? For the people on today's call that I've been speaking with, and that's why I put the example in here, you can use a commercial off-the-shelf vendor's statement of software validation. So some key points. Software testing is necessary activity, but it's not sufficient enough to get the confidence that we need that the software is fit for its intended use. Without going into validation, which again is these use cases and interconnectivity and the things that are being done, how much you got to do, it's got to be based on how complex the software is and the safety risk. Now back to, I added a quick note at the end, coordinate measuring machines, CMMs. Again, most of those are sold by companies that have been in business forever. The idea that their software is going to send you wrong things is probably very low. Now, the chance that your employees set the program up wrong and it got different results, that's very true, which again, documentation, training, audits, and corrective action, but it's not a software validation issue. It's a process issue that involves humans. So the example document that I gave you from Harrington on their HQMS software, it is based on evidence collected from planned efforts throughout the entire software lifecycle. If you got it, use it. Now, whenever software is changed, a validation analysis should be conducted. And what I mean by that is, again, not every change is high risk. So look at the impact of the change on the entire ecostructure. In summary, you do not have to validate all software. You have to validate based on risk. software is not the same as hardware. So when you're engaging with people that make products and manufacturing, you need to slow down a little bit and kind of go through the same stories that I talked about. But most importantly, take baby steps. Do not confuse improvements with perfection. I mean, again, there's people say, well, we can't do anything because it's not perfect. Well, is it better than what you're doing now? So let's look and see if we got some questions coming in. This might have been somebody I already talked to, but they said, I was told by an FDA inspector I have no choice. Quick story on that. I was the director of quality engineering in a tier 1 aerospace company. The VP of quality went on vacation, and I was the acting VP of quality. I got a quality deficiency report from one of the government inspectors. I was 26 at the time, so it's not because I was so smart. It might have been because I was so naive. I looked at what they said. I looked at the requirements, and I rejected the QDR saying, your standards do not require this, which of course made sense to me. Well, the next morning, 6 a.m., I'm going through the turnstiles, and the VP of quality secretary is meeting me. And she said, did you reject a QDR yesterday? I said, yeah, why? He goes, well, Colonel Reinkover wants you down in the federal building immediately. It's like, oh my gosh, what did I do? My heart's pumping. I go in and I said, Colonel Reinkover, my name's John. And he looks at me and he goes, are you the guy that rejected a QDR from one of my inspectors? I said, yes, sir. And he reached out his hand and he shook my hand and he said, congratulations. He goes, I think you're one of the few people down there that ever went through all our standards. So again, by experience, you need to talk to people. I spent about an hour talking with them about what works and doesn't work and how we can improve. Next question. So do the Harrington HQMS customers use your software validation statement or do they revalidate? The answer to that is both. And that goes back to what driving the decision. If you're strictly focused on compliance and an FDA inspector said you had to and you don't want to engage them, then some do. The majority, though, look at business excellence, look at taking baby steps, and submit that as a statement of validation. I got a couple more. This one is testing versus validation is still confusing. And this is, I'm paraphrasing the question, but it's basically like a quality control person making parts. So just to reiterate, testing is testing, quality control, inspection, what you're used to doing in manufacturing. Validation is putting your part, and I'm sticking in the manufacturing example, whatever part you're making or the subassembly or whatever you're doing or the assembly, and making sure the final product to the customer works. So your part might work, but if it goes into another component and it doesn't work, then it doesn't work. And I mean, this is internationally based on product recalls. We need to spend more time thinking about how the consumer uses the final product. It might quote unquote work, but they did this and people got hurt. Looks like we got one more. We're a small company. How do you handle big customers that expect us to act like them? Wow, that is a great point, which I forgot to mention. There's a whole nother subject about small businesses aren't big businesses and how to interact with them. And just example, I had another client, small business, and by small I mean under 20 million in revenue, about 60 employees, that had no customer rejects, no nonconformance reports, no corrective action requests, stellar quality performance. interestingly enough, they were also one of the highest priced suppliers, and they couldn't pass a quality audit. That was very frustrating. I mean, our customers love us, but in comes a quality auditor, or in comes the FDA validation person, or whoever it is. So there's a whole other mentality to try to explain to big customers that we behave differently because we are different. For example, gosh, I don't remember the exact question, but the big company auditor was asking, well, how do you manage, issues, on and on and on. And the owner, put his head down and rubbed his forehead and said, well, here's how we do it. I go out into the plant floor at least 3 times a day. I talk to all the supervisors. I talk to all the employees. Of course, I know what's going on in my facility. How could you not know? So even from his comment, how would you not know? As soon as we started to explain, well, this is the world they live in. This is the world you live in. And this is how you need to explain risk. It all comes down to risk. A little bit more about the Harrington Group. As I mentioned, we have the Harrington Quality Management System. The team is focused on short-term operational improvements with long-term financial results through a blend of products and services, again, based on business. And of course, we're worried about compliance, but you got to have them both. So the team develops in a robust design, like I mentioned, cost-effective quality management software that grows as your company grows. Been in business for 3 decades, over 45,000 customers around the world. And let's see, we got another question that came in. I work for a medical device company. I wrestle with the question of NPS validation for tools we're using in design verification, testing of new design. Lots of pushback from my peers. I insist we need to validate the tools, helping drive a decision if we pass a requirement or not. Is that a valid reason to test a device? Yes. See, the way you ask the question, you're well aware of, we're doing this because this is how it impacts the consumer of our product and how it impacts the business. Those conversations go well. Now, based on what you heard today, and again, give me a call later if you want to chat about it, I guarantee you, over and over, if you go in, we have to, because the auditor said we have to, you will get shut down. And if you kind of walk through this slide deck, which of course you can download with them and say, well, look, here's this, and this is how we behave and how it works, I think it will go better for you. Okay, let me check one more. Okay, I think that's it. Well, thank you so much for your time. I appreciate it. Have a good day.